Oh, slight technical problem there. That's a good start. So welcome, folks. This is the Snyk office hours. I'm sure some of you will have been here before. I see we've got folks starting to join already, which is great. I'm joined today by my colleague, Eric Smalling. Hello, Eric. How you doing? All the way from Dallas, Texas.
Yes, hello. Good afternoon to you, sir.
Yeah, it is afternoon, evening even. Evening, it could be called. Early evening. It's nearly beer o'clock, but not quite. So both Eric and I work in the developer relations team at Snyk. And for those of you who haven't joined one of these office hour sessions before, we're going to explore some of the great product features that Snyk has. And but also we're here to answer any questions you might have. So feel free, if you're watching on YouTube, you're watching on Twitch, feel free to put your questions, comments, thoughts into the relevant comments section. And we will get those and hopefully answer them. If Eric and I don't know the answers, then we will find somebody, hopefully, who does. So today, what are we talking about today, Eric? Snyk Container, I think, isn't it?
Yes, all the container stuff.
All the containers. So where shall we start? I think should we maybe start with should we start with this with the container CLI maybe and take a look at how that works from the CLI?
Sure, we can do that. Let me get my screen share open. Is that font big enough?
Oh, it is. Yeah, that's a very impressive shell there.
I have been converted by our buddy Jim in marketing. He has converted me to fish shell.
Wow.
And I am playing with that lately. So hopefully that'll work for me and not just completely fail in front of live audience. So let's see where I am. Let me go into a directory that has a Docker file. So this is our, if you've ever watched any of my demos before, we have this Java goof since I was a Java developer in a past life. So I'm more familiar with Java than anything else, probably. I've got a Docker file in here. In fact, I've got...
We can start with actually scanning a Docker file then to...
Well, I'm going to build the image and scan it there from the CLI.
Okay, cool. Yeah, nice.
So here is that Docker file. If I can get this to... Is that visible? That's not very pretty. Let me do it in here. I don't want to figure out my IDE settings at the moment. So this is what you might see in a standard lift and shift JEE app. We've got a multi-stage build. It's going to start with a Maven build of a Java app. And then the Tomcat build, or the final stage is a Tomcat base image that just copies in stuff from the build phase, as well as a web XML that we need to run the app. Nothing too fancy. So if we do Docker build, you can see I've already done it. It's probably going to run really fast since I've been playing with this last night. I'm going to get our build of this container. And there's Maven doing its thing. I am using Docker Desktop for Mac, for anyone who's curious. And I am fortunate to have one of the new M1 Macs, which is great for speed, but horrible for base images that don't have ARM architecture builds. So hopefully we won't run into that today. So if we do Docker images, we can see there's my build. So we have a 567 megabyte image. Now, there's a couple ways I could scan this. I'm going to use our CLI tool, which oops, see, fish failing me already. I do Snyk container test. If you've used Snyk before for like code, there's just Snyk test, and it'll figure out you're in a Java project or a Go project or whatever. So here we're specifically calling out the container module, and I want to tell it what image. So I'm going to pull this image name. And it's something you can feed into it. If you do a file equals Docker file, that will give it hints.
Should we do it without to start with and just show folks what happens without, and then we can show what happens when you add that minus file?
Sure, we'll do that. Okay. So this is just going to basically, I'm going to start it up here. It's going to start analyzing the image. It's building the bill of materials, if you will, in the background, kind of figuring out what is in this image, what packages are installed, all that kind of good stuff.
And this is talking to your because this is talking to your local Docker daemon here, right? Isn't it? It's actually getting that image from the Docker daemon.
Right. Now, what's interesting about Snyk Container is it doesn't need Docker to run, but if you have it and you have a local image cache, it will use that as its basis for, what are we looking at? If I didn't have that image, if I did something like, like some of this other image I haven't pulled down, it'll actually in the background go and pull it. And what's pretty cool is that it uses libraries. If you don't have a Docker or other tooling installed, it will reach out and pull the image anyway and do the necessary things to untar it internally and do the scan. But since I have Docker,
I mean, if you do something like Snyk Container test Ubuntu or something like that you don't have locally, and we could see what happens there, right?
Yep. I'll show that one in a second, actually. So what we can see here is my build came in, and it is going through and it's showing me all of these vulnerabilities that it has found, including information on what I could do to fix them. So if I wanted to, I could change my build to upgrade curl, and I could upgrade, curl apparently has a ton. Lots of critical issues. Whatever. I could go through and look at the minutia of that. But what's also interesting is it's telling me right here that it wasn't able to auto detect my base image, and if I feed it this dash file option, that will give it some hints. So let's see what's different when I do that. So dash file equals, and my Docker files right here. It's going to do the exact same scan, but because I'm adding that Docker file, it uses that for hints to understand, here's what base image this really came from. We do have some automatic base image detection for some of the more popular open source official images, but I'll just tell you right now, I'm using a pretty old version of Tomcat that's probably dropped off the supported list for that functionality. And here we go. So now it's exactly the same up here, same vulnerability information, but that extra metadata allowed it to say, oh, you're using Tomcat 8521. And politely saying, that's hella old. So there's all these vulnerabilities in that base image that I'm just coming along for the ride. That's what the majority of the stuff you see up there is. But it also then is able to say, and this is what's kind of cool about our tooling, is it doesn't just give me a spreadsheet or a table of, here's all the problems, have fun with that. It comes back and says, you know what? If you would simply upgrade to a newer version of Tomcat, this case is saying, hey, go at least to 8569. I think 77 might be the latest, but from a security point, if you at least go to this version, it would drop your critical vulnerabilities to 9, and drop all the other ones. Total vulnerability count goes from 705 to 163 just by making that change. And it calls that a minor change because it's just the minor version, the patch version, if you will, that's being upgraded. So there shouldn't be any API problems with that. It's pretty safe. If I wanted to get even fewer vulnerabilities, I could entertain the idea of moving to Tomcat 9, which is a new, possibly could introduce some application, API issues, but it's there. Or I could even get down to these, which it's funny, every time I run this, these are different because new vulnerabilities enter our database, throughout the days. But right now, the Corretto builds, which is Amazon's JVM, are at zeros, which is pretty impressive. But what's cool about this is, even if I'm a junior developer and I don't know much about containers and images and operating system concerns and things like that, I could take this kind of information to my lead developer, to my AppSec folks, my who are middleware folks, and say, hey, these are the recommendations it's making, and have an educated view on it, and say, hey, can we move to these? And I'll put my head architect hat and say, well, Tomcat 9 we can't go with right now because we're not ready to do that. It's a lot of testing, a lot of regression we'd have to do. And I'm not ready to drink the Amazon Kool-Aid here and go to Corretto. So let's at least take a look at a newer version of 8.5. And
I mean, I guess the automatic recommendations is a bit more tricky in the container world, isn't it? Because where we are, in this example, is we're looking at that middleware layer, aren't we? And that if it compared to, so we looked at the CLI and automatic fix PRs like a couple of shows ago. And, if we're talking about, a package that you've included in your application, it's a lot easier to say, oh, well, you know, you're definitely going to want to upgrade that package, right? Because it's a no-brainer. It's not going to break anything. You just upgrade the version of it.
Right.
You know, with middleware, which tends to be where we end up in with base image recommendations, it's kind of much harder because, you know, you look there, you've got a major version of Tomcat, which might have a completely different API. You've got a major version of the different JDKs that are in there, you know, which are almost certainly, you know, have potential breaking changes in them, you know, in terms of big upgrades like that. So it's a bit more of a complex thing, isn't it? More might be interesting for folks who maybe aren't so familiar with containers. You know, if we scroll up a bit and look at the actual vulnerabilities that have been found in there. So these are and obviously we can see it's been introduced by the base image there. We couldn't see that on the first run where we didn't give it the Docker file, right?
Right.
But without the Docker file, we know that this is a Debian based image because, you know, we've been able to detect that in the file system, right?
Right.
So these are actually vulnerabilities that are in a Debian package versions, and you know they've and you know, so you know, you might with a somewhat naive approach, you might be thinking, oh well, I could just go into my container image and start doing like, you know, dpackage -i or whatever and start actually upgrading things. But you know, that there be dragons in the container world, because you really want to know where those things have actually been introduced rather than actually worrying about them, the individual things themselves, right?
Yep. Yeah, the one of the things that, you know, developers, especially if you're new to containerization, that comes up is you're taking on a new context, a new scope of responsibility in this operating system level stuff. All these packages, distributions of Linux, Debian versus Ubuntu versus Alpine. I mean, Alpine's a whole new, you know, it's muscle C. It's not glibc based, so you got to think about things like that. And
yeah, I mean, you may not even be a Linux user, right? All this stuff may be like, you know, you and I have been around the block with this stuff and got the gray hairs to prove it, Eric. But that.
Yeah, I mean, a lot of folks dealing at the application level, you've been handed this, right? You're like, my team uses CentOS, and we have a middleware team that owns the Tomcat or Glassfish or whatever it is we deploy on, and I just produce a WAR, or I just produce, or in the Node.js world, we, you know, we have Apache fronting this or Nginx fronting that. I don't deal with that. Well, now you still have those teams that usually you work with, but that Docker file, that's right in your source code usually, and you need to make sure that, you know, you're at least aware of this kind of information, so you can go to them and say, hey, do we need to upgrade, rather than waiting for them to figure it out and send you a ticket that you may or may not notice. And if you don't, you're going to be vulnerable. Now, another thing that's interesting here, let's say it's recommending I go to this. Let's try this. Let me edit my Docker file, and we'll just change that, and we'll do another build. Oh, come on, fish. Docker build. And I'm going to label this one with a new tag just to keep it separate.
So while that's building, this is an interesting question, which I'm just going to put up on screen here. So how does Snyk Container and the GitHub integration work compared to the CLI? Is that only based on the Docker file without the image?
So yes, so what they're asking about is, we, in addition to the CLI, we have your free Snyk account. You can integrate with GitHub or Bitbucket or whatever, you know, repository you use, and if that scanner, if that integration, that project you create sees a Docker file, it will automatically scan it. And you're right, since there's no image at that point, and we're not spinning up and building your image, because that would be, you know, horrendously huge. It's going to just basically do a static analysis of the Docker file. And to be honest, what it's going to do is going to look at the base image that you're ending up with, and it's going to tell you about vulnerabilities coming in on that base image. without having to build an image. Now, if you want this level of scanning, we also have the ability through that same tool to go after Docker Hub or Artifactory or whatever registry you might be using and pull the image itself down and scan the image. And there is a way to cross-reference a Docker file that it's also scanning, so you can get the best of both worlds. We can look at that in a minute.
Yeah, so let's remember to come back to that, right? So
so I built the image. I'm going to run a scan against it now with that new tag I added to it. Again, feeding the Docker file to it. There's another bit here that while this scans, I'll mention. There are other arguments you can feed all of our test scanners. You can make them be more verbose. You can make them output in JSON format. So you can scrape it in. You can output in serif format. So if you're in a CI server that understands the vulnerability report, the serif report, like GitHub does this, GitHub Actions, it can ingest that, and a lot of CI servers have a plugin or understandability to present that as here's the vulnerabilities found, integrated right into their UI. So now it knows that we're on 8.5.69, and there are no minor version recommendations. There's just the major. So now we've repaired all of those kinds of changes before I've even had to commit and push to a registry or anything. So that worked. Since it was asked, let me open a new browser and let's take a look. I have no idea what projects I have in my personal setup here right now. Let's see, do I have this one in there? I do. Oh, no, I don't. I've been messing around with a lot of stuff lately, so let me delete that.
I think
these are Bitbucket.
I've got one here, Eric. If you want to just,
that's okay. I was going to walk through just how you add it.
Honestly. Yeah, let's do that then.
Those were a bunch of Bitbucket ones I was doing for a conference we were just at Atlassian conference. So I think I've deleted that repository. So I come in here. I'm going to look for my Java goof.
It's on the left.
So, what?
It's on the first column.
There it is. Add. So now it's doing what we were saying. It's going out. I've already set up my integration with a key, my token to my GitHub account. It's going out there. In fact, I can hit this and I can see what it's doing. It sees all of these things in that repository, and it has created 9 projects.
And this is just scanning the Docker file in this instance, right?
Right. Well, so it sees a lot of things and it scanned a ton of things.
Yeah.
But what we're looking at today is the Docker file. So you see the little Moby whale logo next to the Docker files it found. It also found a couple Maven projects and some Kubernetes YAML and other things like that. But let's go ahead and open this Docker file. So we're going to see similar information. It's saying, hey, you are basing your image on 8.5.21. Very, same kind of thing we saw over in the CLI. One of the cool things here, though, if we can scroll down, you can see a prettier version of the vulnerability outputs. See the details about it. You can really dig in here and say, what is this vulnerability? In fact, if I go back and we look at these, you see how these info lines have these URLs. You can open those just like they're linked here. And you can really dig in if you really wanted to get in and say, what is this? Why is this a problem? You can look at all the different external references, CVE tracker, security advisories. Sometimes you'll have proof of concept exploit code that you can actually try to duplicate it. The ratings are interesting. Let me actually come back to this. We have a priority score we apply. And it, by default, it will sort by that. And this takes into account several things. And now this case, it's just using the critical severity, the CVSS score. I don't have a good example in this one, but it'll take into account things like, is there a fix for this? If there's a fix for this, it'll up that some more. Is there a proof of concept exploit available and well known? It'll up the score. Is it being chatted about on Twitter right now?
Yeah,
which is a good one. And our systems and our security analysts are always updating this database with that kind of info. And this gives a good way to, if you've got a bunch of failures, of looking at it and saying, okay, well, which ones do we want to attack in this sprint versus the next one? So that's a nice feature the web UI will give you.
But I mean, in some ways, though, I mean, this is something I've talked about at conferences a little bit. That, you know, in your when you're doing when you're thinking about vulnerabilities in containers, you almost don't want to be digging off into like the weeds of what each of these vulnerabilities are, because you don't want to be focused on fixing individual vulnerabilities that are in the base image. If they're in the base image, you want to be looking upstream for someone else to fix that in a new base image, rather than getting fixated on what those individual vulnerabilities are. Because you know, as soon as you start fixing them in your base image, you're maintaining that base image forever, right? You become the maintainer of it, and you really don't want to be doing that. So if folks are interested in that, I think I gave a talk at DockerCon and at KubeCon on exactly this, you know, strategies you might use. Let me see if I can. I'll find the URL for the video of that. And stick it in the chat.
Yep, a lot of users basically they'll set this up, and their favorite thing to do is click this button over here, this open a fix PR, and confirm it. And now it's going to go out to my, in this case, GitHub repository, create a pull request, nicely formatted up with the things that are getting fixed. And if you look at the change, it did the change to my Docker file. And this can be set up to be done automatically. So if we find, so one of the cool things about the UI, actually, I skipped over, is that even if I don't change my Docker file, day to day, it's going to re-scan. It's not a scan. It already knows what's in there.
It's monitoring it over time. So
yeah, it's monitoring.
New things happen. You know, it's going to be updating that.
Right. And you can set this up to actually open a pull request for you automatically should a fixable base image update happen. So you wake up in the morning, you come in and you see on your pull request queue, oh, Snyk has opened a new one for us because this has happened. Let's review this. Let's test it, do whatever we need to do. Your CI servers probably would have picked this up and done their functional tests and whatever else they would do. And then you can commit it and, you know, hey, free security.
So that's so what we've looked at there is just really scanning on the Docker file.
Yeah.
We can actually link those two things within the UI, though, can't we? That if you know which thing in the registry that relates to, you can. Am I understanding that correctly? That we can do.
So let's do this. I think I'm logged into my Docker Hub account, so I'm going to use Docker Hub. That first one up. So let's push this up there.
Yeah, there's like a box in the UI, isn't there, to associate that Docker file with a particular thing from a registry.
So let me go ahead and I'm going to go into my Docker Hub integration. Oh, I might have cleared this out because I was doing some demos.
Yeah, maybe don't share when you put your credentials in there, Eric.
Yep. Yeah. Well, I'm gonna stop my share for a second. Actually, I'll just drag this off to another monitor. That's always safe.
There you go. What could possibly go wrong?
I recently, my Docker Hub account just got re-updated with our corporate one, and I have to reset some things. I'm glad I'm noticing this now and not before I do a conference talk and show this off. So talks amongst yourselves, Matt. and
yeah. So what can I talk about here? So I think one of the next things that we're going to come to in a minute, hopefully, is like that. After we look at the stuff in the UI, is the scanning from the CLI will pick up application vulnerabilities as well as base image vulns, right, Eric? So you can I don't know whether it does in this particular example. We might have to find a different image, but it's going to pick up vulnerabilities that you've introduced through your own application into that base image. And there's a switch in the CLI to actually filter those out. So you can say, I want to ignore the ones that are in the base image. Maybe another team deals with base images. Maybe, someone else in my team is doing that. All I care about is what's in this base image that I introduced. And we can look at that in a sec.
Yes, there is a flag that's appropriately named ignore.
Yeah.
Base phones, or so I'll have to look at it. But here we go. So I created a new token in Docker Hub, and I added it to my settings in my account here in Snyk. And now when I go into the button that I tried to click earlier, it shows me all of these different registry repositories I have in Docker Hub. And I'm going to add the latest. And it's going to go out. It's actually going to pull that image down now and do an image scan, not just a static scan.
So basically the one we did from the CLI, right? This
basically,
is doing exactly the one that we did from the CLI.
And we'll let this grind away for a second.
So while we're doing that, we've got another question from Brian here about if I install extra binaries using apt, for instance, can we see this in the Docker scan as well? I'm assuming he means when we build the Docker, when we build the image, i.e., if we've got like apt-get commands in the image, and in that case, I believe the answer is yes, right?
Yes, image scans do that. So they actually look at the packages, the operating system packages that you've installed. Now, where you can get yourself in trouble is if you're actually building from source.
Yeah,
and doing it all, rolling your own. There's not much way that we could figure that out. You always want to use official supported packages for your stuff anyway, so it's trusted and whatnot. But it should detect that as part of the scan. Now, the hard part to demo on that is that most apt or yum repositories that you would use have everything already patched. So you're adding something, trying to test it out. It's like, oh, well, you've added this. Well, trying to get a version that's broken is they do a really good job, the OS folks, of keeping those out. So I don't have a good one off the top of my head that I could show you that with.
And I believe there is some work going on in the engineering teams about detecting arbitrary binaries, though, right? Because
yes, that's an ongoing battle. Good example of that was in the Java space, was during the log4shell days, where we have a flag I'll show you in a second called app-vulns that will dig farther than just packages, and it'll actually look for, it'll kind of take into account the code scanning capabilities we have in the other pieces of Snyk's stuff, and it will try to find libraries that are bad, or classes, or whatever. And in log4shell's situation, you've got a jar file generally that is the problem, and app-vulns will expose that. In fact, the Docker desktop and the Docker CLI folks, so there's a Docker scan command that uses with our partnership with them, and it uses Snyk's container scan under the hood. They actually defaulted app-vulns on for Docker scan because there was such a big problem with log4shell that they figured, okay, it's more information than most people want to see, but more information is better right now. And so they've left that on, and we have actual extra flagging in there if log4shell pops up. This is that scan I was just showing you. I just pulled the image from Docker Hub. So if I click in here to look at the latest, it actually digs in more than just a container scan, which is kind of interesting to me. It not only sees the Debian based image, and we're going to look at that in a second, but it also saw, hey, you've got some Maven stuff or some Java applications in here we could look at if you want. Also related to that app-vuln scanning. So here we are on the image. it is seeing that this is a Debian 9 based image at its top level. So it's not seeing the Tomcat aspect of it because we didn't connect the Docker file to it. And so it's saying, I'm not sure exactly, but I know it's Debian 9. And so it's gone all the way up to that level. And it's showing me all the things. It should be very similar to what we saw in the command line before. And it's saying for optimal base recommendations, link the Docker file in the project settings area. So I can go in here. And so this is the settings for this project. Configure Docker file from GitHub. And I can go tell it what repository this is coming from. And I'm going to say Java Oof. And it's that Docker file. And it's going to go do a retest real quick. And give it a minute. It's going to then do that association and kind of cross-reference them. Another cool thing that I'm not going to get into showing right now unless we have extra time. If you use, if you're familiar with Docker labels, which are more appropriately known as OSI annotations, OCI?
OCI.
Yeah, thanks. Sorry. OCI annotations. There's a set of standard ones, and one of them is the source code URL, the GitHub URL, where this image came from, right? If you put that into your image as a Docker label or an annotation, newest version of our stuff now will auto correlate that. It'll see that and it'll bring it in. There's a blog that I may have.
Oh, I could post your blog as well on this.
Oh, yeah. Oh, you're doing the actual spec.
I was actually posting the spec, but
we have a blog out there.
You've got a blog. I've got it here, Eric. So carry on.
And we mentioned it, and it talks all about those annotations, everything you ever want to know about Docker labels. Docker labels is like one of the great features of Docker builds that nobody uses.
Yeah.
You can do all sorts of really cool stuff with Docker labels. But so now we have, it's still not done. Oh, live demos. I'm not sure why it's not linking. That should
should we come back to that in a minute? That's going to come and make those base image recommendations, basically, isn't it? The same as we get in CLI.
Yep. Oops. And there's one. Dang it.
You'll be changing that API token.
I'll be changing that over in this other monitor while we talk. Oh, Eric.
It's all going horribly wrong, Eric. It's all downhill from here.
I told you moving it to the other monitor wasn't going to work.
So back to the CLI. Let's see. Where do we get to? We were going to look at
deactivated. Okay.
We were going to look at exclude base image vulns.
Yes, thank you.
Have we got anything that we can demo exclude base image vulns using?
Yeah, let me think of one.
Because I don't think in this one has got any
this one's not going to be
application vulns in it, right?
Let me see if I've got one checked out that I was using. Let's use. Look at this one real quick. And that one doesn't do any real work either. Sorry, I should have had one of these on my mind.
That's all right. I should have thought about it as well. Does that are you sure that node one?
It's doing an npm install. It's not doing any kind of installs. Let me look at my Python one. I've been working on trying to get a Python demo going here. So this is.
So while you're looking, I'm going to answer another quick question. So this is from our friend Brian Clark saying, I may have missed it if it was discussed already, but what is your advice when choosing images for our projects? It feels like there aren't many vulnerability-free images. This is very true. And in some ways, again, if you the video that I posted earlier from KubeCon where I talk about this is a good starting point, because zero vulnerabilities in a container image is probably not a great goal, right? Because it's almost impossible. I mean, unless you're going to you've got a compiled binary in Go or in C or something where you don't need anything else in that image. It's very, very hard to get to zero. So the advice when choosing images, is you want to be looking at slim versions, not if we talk about the sort of standard library images are probably not the ones you want, so you probably don't want the upstream Python or the upstream Java image, the standard one from the container from the language runtime, because they're going to have everything in them, right? So multi-stage builds is the way to go.
Actually, no, sorry, I mean to interrupt.
No, go on.
So actually, just gave a presentation on this at Atlassian Teams. Let me actually show this slide because I think it speaks right to what you're talking about. There's when you pick your base image, and Keynote has now taken over all my monitors, so hopefully you can see my slide. Can't tell.
That's API keys. That's all I'm seeing.
Oh no.
No, you're fine. You're fine.
You're scaring me. So when you choose your base image, you've got options. So you can choose the most general, which would be like at the top here, you got Python 3.
This is what I was talking about, right?
Yeah, what version of that is that? What patch level? You don't know. Some people like this because you're always getting the latest Python 3. And if you're doing continuous delivery where you are just cranking out a build an hour, maybe that'll work for your team. But most people want a reproducible build from a given Git commit. So I'm a fan of going at least to the Semver 3.10.2 in this case, or the Caliver, depending on what kind of versioning they do. You could go all the way to the SHA hash, which is completely reproducible, and you always know what you're going to get out of it. But that's a little harder to get buy-in from your developer teams. The other thing is, as you were talking about this, there's the other versions of that now. If you use 3.10.2, that's what I like to call the general version of an image.
Yeah, and that's going to have every single kitchen, because it's got to be for every possible Python application should run in that image. So
yeah, this is what you use on your developer desktop, right? As you're working on it, you need everything that you might want to have all at once. But you see, that's a gigabyte in size nearly. If you use the slim version, which is based on the same, in this case, Debian backend or distribution, but they rip everything out that's not needed to run a Python 3 app, pretty much. And so it drops it all the way down to 123. And from a security standpoint, that's important because you don't want curl, for instance, in your image, because if somebody does exploit something in your application or in Python itself, and they get a remote code execution exploit going, if you give them tools to use, they will use them. And curl can be used to go get scripts or go get things off the internet or do things, right? So you don't want to give tools to the hackers. Some people also like to go with Alpine, which is a distribution that is built on small footprint and security in mind. In this case, you can see it's only a 48 megabyte base image. This one's great. The only negative to Alpine's, really, in my opinion, besides there are some licensing concerns. If you some places don't like the BusyBox licensing, which it's based on, because there's been a lot of they kind of are fairly litigious. So if that's a problem, you have to keep that in mind. But everything in Alpine is built with muscle C instead of glibc. So if you've got any kind of binary dependencies, if you're doing Java and using an Alpine-based Java image and you do any JNI, that could break you. If you've got any compiled, SOs you're bringing in, which is a whole discussion to itself. But the other ones are these distroless images. So the Google team has a bunch of what they call distroless Python, Java, whatever, which are based on Debian, but they strip out the shell, they strip out the package manager. There's just nothing else in there, literally, except for Python and its libraries. These are good.
Cool.
Do what?
I like distroless. It's a good place to start for most things.
They are very good. The negatives to distroless, and for some teams, are they do not do tagging like this. They don't. They expect you to always be pulling the latest. So your Python 3 Debian 11 at the time I wrote this slide that was the thing for Python 3. You don't get to say 3.10.2.
Of course, we should point out that there are no security vulnerabilities in Python, of course.
Of course. So, it's perfect language.
I have no idea why you're picking on Python in this example. Well, as a long-time Python developer.
So to show you an example in Ruby then. So using a general image like Ruby, you can, this works for this Rails app example, right? All I'm having to get is a SQLite 3 package just so that my Rails app can connect to the database and do its thing. But this is the kitchen sink version. It's the almost a terabyte or gigabyte size. The other side of that, if I go slim, now I've got to manage every package I need to build and run my app, which is also not great because I'm becoming an OS expert at this point and thinking, I need Ruby dev, I need libpq dev, and all that crap. The nice happy medium is that we started to say these multi-stage things where I build the app in stage 1 with the general, but then in stage 2, I just pull in I go to the slim version of it, and I just pull in what's needed for my gems and my app.
Yeah, just for runtime.
Right. This is kind of the best of both worlds. So perfect time.
Handy presentation, Eric.
Yeah, handy.
Almost like you pre-prepared.
No, my buddy Marco and I presented that in Vegas a couple weeks ago. That's the multi-stage build came out in 2017, and it is one of the best advances pre-build X in the Docker world.
I mean, it's surprising how there's still quite a lot of people who don't understand multi-stage builds still.
Yeah,
even though it's been around for such a long time.
It's not a silver bullet. I mean, there are still things you have to take into account. Some of the other things that are really cool that have happened in the Docker building world are actually using tools other than Docker build. Docker build's great, but if you are on an OpenShift platform and in a Red Hat world, you're probably using Builda.
Yeah,
their tool set that comes with they're dealing
with. Work with Builda, very cool.
If you're a Go shop, a lot of people doing Go are using the tool Ko.
Yep,
which is a Dockerless it doesn't need a runtime engine to do a build. It understands Go build and it understands how to build an OCI compliant image from that. In the Java world, there's a one called Jib. I love Jib. Jib's great. It's 100% JVM implementation of a container builder, and it doesn't need a runtime engine. It's great if you are like in a Jenkins environment, right? A lot of Maven shops are also using Jenkins because they've been around a while, and that's just the tool they use. Classically in Jenkins, your build agent nodes, you have to bind mount in the Docker socket into the workspace that the build is happening so that it can build an image. And that's such a security risk because you're basically giving that build script, that Maven, that agent root on that box when you do that.
Yeah, I mean, I think we're probably going a little bit into the weeds for those who are outside the world of containers. But a lot of these things are to do with that historically, Docker required a lot of permissions. That when you start doing things, at scale. You don't want a daemon to have that set of permissions. So a lot of the new ways of building containers are, kind of building things rootless, where you don't need root in order to build an image. So you can do it in your Kubernetes cluster, you could do it in your CI pipeline because you're not, you haven't opened a big security door by having something with root. Right, where do we get to? This is like our usual conversations, Eric. We've gone off on all sorts of tangents.
Let's see. I built this Python test. I want to see if pip packages. If I scan it once and then I scan it again with the ignore base.
Whether we get a difference.
What difference I get. So let's see what this comes up with. Brian Clark asked, is there a way to see the difference between regular Slim and Alpine versions? That's a great question. And the only way I would know to do that would be you could pull a package manager list from each and do a diff. So you could do docker run -r/-it Alpine, and then as the command do whatever the APK version of that is, and do the same thing with Ubuntu or Debian and do a dpkj-l, and just you'd have to do a manual comparison. I don't know of any automated lists, but that would be interesting.
No, I don't. I mean, normally people just look at the size.
Well, it's usually about what tools do you need.
Yeah.
So if you need curl, is it better to go with the big general image, or is it better to go with slim and then add it? I would say go with add it, because it's a declarative, I need this.
Yeah.
And you can, in your Docker file, you could comment why you need it.
Yeah, I mean, I mean, that's a good general principle in all things, right? Is the particularly around security, is start from a position of having everything the absolute minimum, and then adding things is a much better place than trying to remove things. So this is the -- exclude base image vulns, right?
Right. So what we came up with here, I didn't feed the Docker file, so it doesn't know the base, but it's saying there were 297 issues. I'm gonna run it again with the ignore the ones from the base image. Now, even though we don't know which base it is, it knows from the hierarchy. Kind of, I think it knows. We'll see. If this doesn't come up any different, I'll feed it the Docker file. We'll see. Where this option comes in play is usually in large companies where you have custom base images, where mycorp/Java 8 is the image you use. You're not allowed to use like an external one. You've got the company approved one. Yeah, so that didn't come up any different. let's feed it the Docker file so it knows. So instead of Python 3, you've got my big company /Python 3-instrumented, which has Python 3 plus the big brother monitoring tools that we use, whatever. And those are produced by maybe a middleware team, and you always use those. And it's up to those folks to make sure any known vulnerabilities are mitigated, and they don't want everyone else worrying about that. So here we go. So this is interesting. Since I fed it the Docker file, no vulnerable. I have not added anything vulnerable on top of that base. That's what that line is saying. Now it's saying the base image itself, you could do some things, but it's not showing me the vulnerability list of anything that is ahead of my work. Would be interesting if I added something that was vulnerable, but I can't think of anything right now.
So I wonder what other interesting flags there are in the depths of Snyk Container. Do you want to do Snyk Container -- help and just have a look through?
Yeah, let's see. So we've got you can print the dependency tree.
So yeah, we looked at that one the other day, I think.
Yep. Let's read.
Are there any specific to container? What about the app vulns?
Oh yeah, that's a good point. Let's do that one actually. We'll use this Python one and do that with it. So I'm going to spit out, and I probably should leave the file on there actually.
So app vulns allow detection of vulnerabilities in your application dependencies from container images, as well as from the operating system, all in one single scan.
Yes. These are a bit more wordy. This is going to dig down and find, I'm going to guess on this image, based on what I know about this image, is probably going to find some things in the celery package, because I think this is a vulnerable package, or vulnerable around that. So you can scroll up, we see the normal container stuff here. If I scroll way up past the output from the container scan, lots and lots of stuff. Probably should have put this to a file. Oh my goodness. Just grab this.
Pipe it to more.
You know what? I'm going to do a Java one because I know that better.
Yeah. This makes more sense in the Java kind of world anyway, right?
I think so, yeah. So I don't need to rebuild the image. Let's do Snyk container test app vulns, but we're going to do it on Java. So you remember this was the one I did earlier that's based on the, oh, did I type that one? Huh? Docker images. Oh, it's got a dash. This is the one that's based on the old version of Tomcat, which Tomcat's middleware is interesting because it's a base image, but it's a base image that includes middleware. And this one should show us a couple things. One of them being an RCE in the Tomcat admin module, I think, jar, as well as log4shell. And as I was saying earlier, log4shell is an interesting case. So here we go. Here's the special flagging we added for log4j versioning. So it's saying, hey, if you don't want to look through all the stuff above, at least know this: you have log4j at a vulnerable version in here, and some advice. If we scroll up now, you can see this is a lot more stuff in here than we saw in a normal container scan. So it's looking at
so this is found deployed Java code that it's then gone and tested separately from your container image.
Yep, it's saying in this image at path user local Tomcat web apps examples webinf lib, nothing found. It's just going, it's traversing through the file system and looking for stuff. So here's one.
As opposed to when it's doing the container image scan, it's actually interfacing with the package manager, right, from the operating system.
Exactly.
So whether that be RPM if it's a Red Hat thing, or apt if it's a Debian thing.
Yes. So I'm going to go to the top of this chunk. Yeah, so it's just giving more information about the jars themselves. And one of the things that you can help it with, let's say you have a shaded jar.
Yeah, so for those of us who are not Java developers, Eric, what's a shaded jar?
A jar is just a zip. So it's just a fancy named zip file. And it contains all the bytecode, the class files of a Java application. So you compile your Java to class files, and then package it up in a jar. And it has metadata around it too, but it's basically a zip of all those classes in their directories for where they need to live. It can also contain other jar files. You can have jar files embedded in jar files. And we call that nested or shaded jars. Shaded is a loaded word. It also could mean that you've taken the class files out of one jar and put them into your own. And that's actually not uncommon as well. And you can repackage them. So what you'll see is a vendor. There was an application monitoring vendor that during the middle of all this log4shell stuff that they had packaged a vulnerable version of log4shell into their jar file, which you then include as a dependency of your application in order to be monitored. And the reason they do that is because they repackage it into a different Java namespace so that it can load its classes aside from whatever version of log4j your application might load. And Brian V, I think, is on the call. He can let me know if I'm going off the rails on that. But that way you can actually have two versions of a library and use them because they have different package names ahead of them. And that's really hard to find because it's not the signature of the name of a jar. It's not the hash of the of a file anymore because you've changed the name and you've changed the first line of the file to have a different package. And there are arguments you can feed. Back to the help on this. Oops. Snyk container. Dish, come on, give me my help. There's an argument you can feed into that says nested jars depth. If you use app_vulns and this, you can tell it how far you want it to go looking through jar inception style. We found a jar, let's unpack the jar. Let's look inside of what's in that. Oh, we found a jar inside the jar that's inside the jar. Let's keep unpacking, and how deep do you want it to go?
How deep do folks build these things then? Is this a common use case that
It's common. So one of the things you'll see is like Spring Boot. If you want to have an executable jar file, you build a Spring Boot MVC app that's going to be one of your microservices, and you just start that thing up with Java jar, boom, and it starts up. That's one jar file. You might have 100 libraries, transitive dependencies of libraries in there. It's going to have all of those jars in there as well. How many levels deep are common? I couldn't say. Maybe one of our Java experts on could pipe on and say how many they see, but that is the quandary is there's an infinite level you could go to, and we don't want to get into an endless loop doing the scanning. So you can tune this with that argument to say how deep do you want me to look for this. I don't know what the default is. I know it's at least one level. That'd be good to know. But if we look at, I'm going to run this again with, well, I know I don't have a nested one in here.
Yeah.
I can't show you an example of that. I don't have one handy, but it was necessary in the middle of all this for people to find things, because vendors will do this, and they have to do that, because otherwise you would have to pin your application to the version of, in this case, log4j that they're using, or or use some other logging.
So I had another quick question that came to mind when we were just looking at the CLI help output there, right? So we can specify -- platform equals. So like for multi-architecture images, specify the platform to test. Mm-hmm. So like what happens if you do, so you're on an ARM platform there, right? On what happens if you specify AMD 64, for example, which is the Intel.
I don't know.
I've never tried this. I'm intrigued to see what would happen.
Let's do this. I'll do it with one I don't have. I copied that, didn't I? No, I didn't.
Because by default, it's going to scan the ARM ones, right? If you're on ARM, I'm assuming it's setting platform equals.
I don't have experimental features turned on with my Docker daemon. This is quite interesting, actually. So if I come into Docker, and we're going to go in here to experimental features.
Oh, okay.
I'm going to turn both of those on, actually. Bounce my Docker daemon. While we wait for this, actually, another thing that we're running low on time, I was going to mention, because the Docker
we're down to a last minute or so.
So those of you who use Docker Desktop you're going to want to attend DockerCon. It's virtual. Register. There's a bunch of stuff coming out that you're going to see on my screen that you probably don't see on yours right now, because I'm a Docker captain and I have access to things. I've gotten approval to talk about them. So there is a feature called extensions that they announced last month, and they are UI extensions you can add. For instance, I can come in here and scan right from the UI. So if
that's cool. I like that.
Scan. I can just pop that in there and not have to type anything. Just do the scan right here, and sure enough, there's the vulnerabilities for that image. This build of this, I have one of our builds that has a couple bugs in it, but I was going to show quickly one of the cool things it'll also do is my build isn't showing this for whatever reason, but it will show base image recommendations right in the tool,
directly in Docker Desktop,
and it's as pretty as the web UI without having to go create a project in the web. Just fancy. So I've turned on experimental options, I think. I know when you do a Docker run with platform. No, I didn't. I turned on. I don't see that option in the experimental options. And we don't have time to really get into it. I know if you do it normally,
we're out of time here, Eric. So we may have to revisit this. I think we've still got some more stuff to prod at for containers. I think we'll have another container show in a couple of shows time. But before we do go, I just wanted to give everybody the next office hours is June the 16th. No, it's not. It's May the 31st. With my good friends Brian Clark, Brian Vermeer, Micah Silverman, I'm not quite sure what they're going to be talking about yet, but you can join them then, and you and I will be back on June the 16th, where we're going to be going through Snyk IAC, I think, Eric, aren't we?
Oh, cool.
It's going to be a bit of an early start for you. I think we're on EMEA time, so it's going to be like 5 a.m. your time.
Yay! You'll get non-shaved, Eric, on that one.
But thank you, everyone, for joining us. I hope you found this useful. Reach out to us on Twitter. Join the Discord server. Have we got the link for Discord somewhere in here? No, I don't think I do. Oh, no. No, I don't have the link handy. But please do join us for the next office hours. And thank you for joining.
If you go to devseccon.com, the link to the Discord is on there.
Awesome. Thank you. That's great. Right. See you folks later.